Here we're asked to find the domain of a complicated function. It's a tall square root of a fraction, x minus 4 on the top, x on the bottom, and write your answer in interval form. Now the thing we have to be careful about is choosing only x values for this domain that do not violate any rules about the square root of this fraction. The first problem, we need the stuff under the radical sign, that's called the radicand, to always be non-negative. It has to be greater than or equal to 0. Okay, so let's go ahead and let x minus 4 over x be greater than or equal to 0. To be greater than or equal to 0 means that we need this fraction to always be positive. Well, let's make a sign graph to find all the x values that make this fraction positive, greater than or equal to 0. Let the top equal 0, so x minus 4 in the fraction will be equal to 0. That gives us a critical number, x equals 4. Let the bottom equal 0. X equals 0, that gives us the other critical value to partition our number line. So we're going to use these two real number solutions to the top and the bottom and to partition our number line. So we'll put an x-axis and we'll bust it up at x equals 0 and x equals 4. And then we'll figure out the sign of the entire fraction, x minus 4 over x, in each of these three regions. First, we see in the first region, well, look, we're just going to put a parenthesis on the top, a parenthesis on the bottom for each region to see the sign of the fraction. And then below the arrow, we'll put the sign of the entire fraction. Now, choose a value in the first region, a value smaller than 0. A safe value that's easy to calculate the sign for would be x equals like negative 100. Choose any value smaller than 0. Now, do the work in your head. Plug it into the top, you get negative 100 minus 4. X is negative 100 equals a negative result. And on the bottom, x is just negative 100. Negative divided by a negative is a positive. So in the first region, the fraction is positive. For the second region, between 0 and 4, choose some number. Let's say x equals 2. Plug it into the top fraction. Positive 2 minus 4 gives you a negative, and then a positive 2 on the bottom. So a negative over a positive gives you a negative. And finally, choose a value greater than 4. Let's say x equals 100. Plug it into the top. 100 minus 4 is positive over 100, which is positive. A positive divided by a positive is positive. Okay, so we need the entire fraction to be greater than or equal to 0. We need it to be positive, so we're going to shade all the regions that make the entire fraction positive. So that means we are shading the left region and the right region, but not the region in the middle. Okay, so shade the right with an arrow, shade the left with an arrow. Now, what about the endpoints? The endpoints for our shading are 0 and 4. This is a bit complicated. We had an inequality sign at the beginning that had an equal portion in it. It was greater than or equal. That means that we usually include our endpoints with the boxy brackets. Or that's normally what we do. We include them when there's an equal portion in it. But this is a fraction, and we have to be careful not to get a 0 denominator. We want no zeros in the bottom of the fraction. We cannot have 0 in the bottom of our fraction. So what we're going to do is include the endpoint x equals 4, but exclude the x equals 0, because if x were equal to 0, that would give us a 0 in the bottom of our fraction. So include x equals 4 with a boxy bracket, exclude x equals 0 with a round bracket. So we go back up to our graph, make the round bracket on 0, the boxy bracket on the 4, and that would represent the graph of our domain. And in interval notation, the first interval is open bracket, negative infinity, comma, to 0, open bracket, union together with boxy bracket 4 to positive infinity.